First we write the balance symbol equation and make note that the acid to alkali ratio is 1 to 1. And then find the number of moles of sodium hydroxide in our solution by multiplying the volume of sodium hydroxide by the concentration of sodium hydroxide divided by 1,000 centimeters cubed, which is to give us 0.01 moles of sodium hydroxide. We note that the ratio of sodium hydroxide to hydrochloric acid is a 1 to 1 ratio. Then we have 0.01 moles times 1,000 centimeters cubed divided by 15 centimeters cubed to give 0.6 recurring m, which is the same as 0.6 moles per decimeter cubed of hydrochloric acid. Right, here is a similar calculation where we have sodium hydroxide and hydrochloric acid. So it's still a 1 to 1 ratio, which is here. Just underline it there. So it tells you that you've got 1 mole of sodium hydroxide reacting with 1 mole of hydrochloric acid. You do the same sort of thing where you have 25 centimeters cubed of 2 mole of sodium hydroxide, and it reacts with 20 centimeters cubed of hydrochloric acid. What's the concentration of the hydrochloric acid? You've got 2 known values of the sodium hydroxide, which you multiply together and divide by 1,000, because as we say, when the technicians make a litre, which is 1,000 centimeters cubed of a solution, it's always that number of moles in that litre which gives you the concentration in moles per decimeter cubed. And then, now we've got 0.05 moles of sodium hydroxide, we assume that the same number of moles are in the hydrochloric acid. So that's what I've written here, because the ratio is 1 to 1. And to find the concentration of the hydrochloric acid, we use the 20 centimeters cubed there, and the 0.05 centimeters cubed here, there, and multiply them multiply the 0.05 moles times 1,000, because we're scaling it back up to a litre, divided by the 20 centimeters cubed, which is in the equation originally there. And we get 2.5 m, which is the same as 2.5 moles per decimeter cubed of hydrochloric acid. This example 2, we have a 2 to 1 ratio of alkali to acid, where you've got potassium hydroxide and sulfuric acid. So we've got a 2 to 1 ratio here. Let's write it there. And this time we do the same thing, where we have the volume of the alkali and the concentration of the alkali multiplied together, divide it by the volume of 1,000 centimeters cubed, so we get 0.002 moles of potassium hydroxide. Then, because that's the 2, to make it a 1 with the sulfuric acid, if 0.002 is the 2, then 0.001 is the 1, okay, which I've written here, because it's a 2 to 1 ratio, so that the number of moles must be also 2 to 1. So now this is the number of moles of sulfuric acid, and to find out the concentration of the sulfuric acid, we have our value of 0.001 moles scale it up to back to 1,000 centimetres cubed, divided by the volume that it's contained in the equation there, and we get 0.04 moles per decimetres cubed, because that's what M equals, moles per decimetre cubed. And that's your answer. That's the concentration of the sulfuric acid.